So good evening everyone and welcome to the webinar on debugging using GDB, which is going to be an interactive workshop. So my name is Mubin and I work as a technology head at Emertxe. I'm having around 20 years of work experience. I'm a computer science graduate, passed out in the year of 2003. And since then, I worked in different companies, including Novell, HP, and currently working at Emertxe as a technology head, primarily managing the technical team who are responsible for delivering trainings in the area of embedded systems, IoT, and full stack web application. So if you have attended our previous webinars, this is a continuation of what we have planned in the series of technical webinars. The last webinar was about how to get started with programming, competitive programming, and we saw how we could write different types of programs using a platform like LeetCode and sharpen our programming skills. So today's workshop is going to be a short interactive session on how to use GDB, which is a very popular debugger applicable in used in the Linux, Unix world as well as in the Mac world. So we will see how we can get started with GDB to debug C programs. So in brief, that's what we're going to learn. So as a prerequisite, if you want to basically try along with me, you can also open your laptop and open a terminal and follow what I am also doing. If you don't have a system in front of you and maybe watching on your mobile, that's also fine. So what you can do is later on when you want to practice, you can follow the video and try to get started with GDB. So brief agenda for today's discussion. So I'll talk about what is GDB, and we'll get started with a quick overview and a walkthrough of how we can use GDB to debug a simple application using the most important commands. And after that, we will see a few further basically commands which are commonly used in GDB. More on this we'll discuss shortly, like commands to print the source code, command to put breakpoint, command to basically continue the code, command to interactively debug and analyze the values of a code or a function, etc. So after that, we'll see how we can like attach GDB to a running process. So it's not necessary that you have to run a program using GDB from the beginning. It's also possible to attach GDB to an existing process which is running. So many a time what happens is that you may have a program which is like a daemon program which is running in the background, and you may find some bugs in that existing application, and it becomes often difficult to like reproduce those issues. In such cases, what you can do is you can run the program, and later whenever you need, you can attach GDB and analyze the code as well. Finally, we'll have a look at how to use GDB to debug threads. So multi-threading, if you are familiar with, is a concept which is generally used to write programs to improve the efficiency of programs, and it is often used in embedded systems as well as non-embedded applications. So we have like multi-threaded programs. So what happens is it becomes difficult to analyze the code without using a debugger. So you may want to basically put a breakpoint in a specific thread, and you may want to analyze different threads to see how they behave. Okay, so in such cases we can make use of GDB to use the thread specific debugging commands to analyze the code as well. So this is in brief what we're going to discuss in today's session. So it's going to be an interactive session, so I will not be like using slides here. It's going to be more of hands-on, and I will also have a cheat sheet with me which contains a list of commands which we will be using in today's session. So if you have any questions, you can feel free to post in the chat box in the question window. I'll be happy to answer. All right. So I'm going to turn off the video for a moment because I'll be sharing the terminal. All right, just a moment. Okay, so can you just confirm if my screen is visible again? Okay, thanks for confirming. All right. So what is GDB? Okay, and why it is used in general. So GDB is a very popular debugger. It's from GNU or GNU. Primarily, it was created by Richard Stallman to debug different high-level applications. So GDB is not only used to debug C programs, it can be used to debug other programs including C++, Java, etc. So in this webinar, we'll see how to debug C programs. We'll not focus on C++ or other programming languages. And further, let's say you're going to work on C++, you can use GDB to debug C++ programs as well. So what is the use of GDB? Now the question I will ask you is, typically when you write a C program, let's say you come across a problem in your code, how do you debug? Let's say you've written a program and you expect the output to be something, but the actual output varies from your expected output. So what can you do in such situations? What will you do? Right, so line by line checking of syntax, Rahul says, by checking the flow of program from main, Saurabh is saying. Okay, good. Check for each module output, Saujanya is saying. Okay. Finding the error and bugs. Okay, so how do you find the error and bugs? So what is the way you will use typically? Let's say you're not using a debugger. How do you find errors? Yeah, so Abhay says add debug print statements and check the flow, right? So that's what typically most of the programmers do. If you're going to write a C program and you wanted to basically check whether the program is behaving as expected, so you'll have to add some additional debug statements just to see the program execution as well as program flow. So what we'll do is that we'll add some print statements, let's say wherever required. Maybe it could be inside a function, at the before a loop, after a loop, right? So important variables, whatever you think, right, you should be analyzed, you can print those values. And if, at times you will see that certain part of the code may not get executed, etc. Right? So you want to check whether it's entering the if condition, or is it going to the else part, right? Is it entering the switch case, etc. So what you can do is that you can use a print statement to debug it. So Yash is saying by using Selenium tool. I'm not sure whether you can use Selenium to debug a C program. Okay, so maybe Selenium can be used to debug other applications, but may not be a C program. So here we're going to focus on how to use GDB to debug a C program. All right. So what is the problem with using print statements? Can you tell me? Is it easy or is it painful? Print statements, how easy is it to add? Yeah, it's quite painful, right? So you have written a code, and to see whether the code is working or not, you'll have to modify the code, isn't it? You'll have to modify the code, and you'll add print statements appropriately whenever it's required. So code may look ugly, and often what happens is that you add a print statement, comment it, you add another print statement, you comment it. So code becomes ugly, and your development code versus production code will be very much different. So yes, you can use print statements to debug simple programs, but it becomes quite difficult to debug large programs which contains multiple files and which are spread across different basically folders, etc. So you can use GDB to analyze your code and find out bugs in your program, right? And you can also use, at times what happens is that you end up debugging a code which is written by somebody else, right? So you don't have an idea about how the code runs. So one of the use of GDB is that you can analyze how the code flows. Let's say you don't want to understand how the code is executing, and it contains certain basically complex logic which contains like functions spread across multiple files, and maybe it uses function pointers and so on. So in such cases, you can use GDB to also understand how the code flow works. So GDB is a tool, it's a command line based tool which can be used to debug and analyze your programs. So what we'll do is that we'll get started with a quick overview and walkthrough, okay, of how to use GDB. Okay, I hope my terminal is visible to you. Can you please confirm? Okay, thanks. Confirming. So before we get started, it's important that you install GDB, right? So I'm using Linux to debug. Nowadays, in Windows also, you can use WSL and install GDB. On Mac also, GDB is supported. Okay. So to check whether GDB is installed, you can just run the command GDB and see. Yes, in my case, GDB is installed. So that's why it's showing this initial messages, some license information, etc., and so on. Okay. So I'll not run GDB. I'll quit GDB. I'll say quit. Okay. So it's a command line based debugging program. So I'll quit GDB and let's see how to get started with GDB. So I have many files which are C programs here. So idea is you should be able to debug any C program using GDB. So let's say you want to debug a simple program. Which uses arrays. Okay. So hope you can see this code. So here it's a simple program which actually uses arrays to write this program. We are using an array to write this program. So there are two arrays, A and B, and A contains some values and B also contains some values. So we are doing a copy operation here. We are copying the contents of A to B and printing the value of B. It's a simple program. So idea is not to basically worry about the program now, but it's before we actually start debugging, you should have some basic idea about how the program looks like. Okay, so what I'll do is that this specific program, I'll run it without using GDB just to see if it's compiling or not. I'll say GCC. Okay, let me zoom it a bit and I'll execute that. Okay, I'll compile it. I'm running it. You can see it's printing 1, 2, 3, 4, and 5. So this program creates two arrays and it's going to copy one array to another and it's going to print the copied array. So very simple program. So I'm going to demonstrate how to use GDB to debug this program. Now this program does not contain any bugs, but I wanted to just show you how to get started. So to run any program using GDB, you can use the command GDB followed by the program name. Okay, so I'll say GDB and a.out. Okay, the syntax to debug a program is GDB and program name. Okay, so that's the syntax, GDB followed by the program. So notice this program name is nothing but the executable. Okay, should give the executable name, not a C file name. So I'll do GDB and a.out. You can see what happens here. All right. So notice here, it prints the last line, which it prints is important. It says reading symbols from a.out. No debugging symbols found. Done. Okay. So when you get this message, it's important to understand that GDB cannot debug this program because it is not able to find any debugging symbols in it. So what it means is that to debug a program, the program should contain debugging symbols, okay, which includes like the code, etc. Now, so what is the correct way to debug a program? So you have to compile the program to enable debugging symbols. Okay, so to compile the program to enable debugging symbols, I can use GCC and I can use the option called as -G. So this is very, very important. Okay, so -G option tells the compiler to add debugging symbols to the executable. So this program, okay, I'll compile it using debugging symbols. Let me call it -O and I'll give the same program name. Okay, I'll say this only. Right. Okay, so you can see this executable got created. And if you look at the file, copy array loop. Okay, it's an executable file. All right. So I can also check using file command and see what type of file it is. Okay, so file command can be used to check what is the type of a file. Sorry. Okay, so you can see here copy array loop. It's a executable ELF 64-bit executable program, and one message you can see here with debug info not stripped. Okay, so whenever you see an executable with debug info, that means you can debug that program. Okay, whereas if I do file on a.out, which was compiled earlier without -G option, it says, you can see the difference here, right? Here it says with debug info. Here you can see there is no debug information. Okay, so just to make you understand what is the difference between an executable compiled using -G option and what is the difference between executable which is compiled using without using -G option. So this one is compiled using -G option. This one doesn't use the -G flag to compile. Okay, so the difference is here we have debug info, here we do not have any debug information. Is that clear? Okay, so let me show you once again how to compile using debug option -G program name. This is optional. I hope you are aware of this. You can say -O and the program name, which will generate the executable as per the name. So let me do this again. So this will generate the executable. Now if you run it, it will run normally. Okay, so the program will run. So let's get started with GDB now. All right. So let's see how we can use GDB. So to use GDB, we can say GDB followed by the program name. I'll say this is the program in this case. Okay. So GDB and the program name we can specify. So what it means is that run the program using a debugger. Okay. So let's run this using a debugger. So as soon as I do this, you can see here the last line, reading symbols from the file. Okay, it's done. It's able to read the symbols from this file. That means the executable can be debugged. So what is the first thing you can do, right, when you want to basically run this program? So by default, you can observe that it is printing this message, the program is not run. Okay, so to run the program, so I'm going to introduce one by one commands. So you can observe what I'm doing one at a time. Okay, so GDB has not started the program yet. To start the program, you can simply say run. Okay, so this is the first command. You can make a note of this. Run a program, you can say run. The program will run, you can see, and it's showing the output 1, 2, 3, 4, 5. Okay, it says process terminated. Okay, the process has terminated. So this was a quick introduction of how to debug a program using GDB. Now usually you don't do this. You'll have to basically analyze the code by putting a breakpoint and by doing single stepping, etc. So let's do one thing. Okay, let me show you few more commands which are useful. Now here you can see you're not able to see the code, right? So to display the code, you can run the command list. Okay, you can say list. So list command will display the code. You can see here it's going to display the code 10 lines at a time. Okay, I'll say list. List will show the code 10 lines at a time. I'll do list again. The remaining 10 lines is going to display. So now it displayed first 10 lines. Next, if I want to print the remaining 10 lines, I'll say list again. Okay. Again, I'll say list so that it can print the remaining code as well. Okay, so it says out of range because this is only containing 20 lines of code. All right. So let me clear this. We can clear the screen also. I can say Control L to clear the screen. So list command L list, right? It has a shortcut. So most of the commands has a shortcut, which could be single letter shortcuts or 2-letter shortcuts, etc. So list command also has a shortcut. Instead of list, you can use the shortcut L. So L can also be used to display the code. Okay, so here since it has already displayed the code, it says it cannot display beyond 20 lines of code. So what you can do is I can say list and I can say 1, right? So I can say 1 or 10, let's say. So I'm saying that display the code, let's say I'll say 5. Okay, list 5. So what it means is that display the code around line number 5. Okay, display the code around line number 5. So it's going to display the code around line number 5, 5 lines before, 5 lines after. Okay, so please make a note of this. So list will take a line number also as an argument. Okay, so that means display the code at that specific line number, around that line. So list line number means display code around 10 lines of code actually specifically. Okay, lines of code around the line number. Okay, that's what it is. Now let me know if any other questions. Yeah, so question comes, can you list the code at once? It's possible to list the code at once. Example, I can do list. I can say list or L and say, for example, 1 to 20, right? So it's going to show 1 to 20. It's like a page by page it's showing, right? You might be familiar with more command or less command. So I can press a space or return so that it shows the remaining lines of code. So that's a good question. You can say list or L followed by starting line and ending line. So this means display code 1 to 20. Okay, that is an option. Okay, so list command can be used to list the source code. Now let's do one thing. Okay, let's see how we can actually debug the program. What does debug the program mean? So debugging the program means you can interrupt the program. GDB can interrupt the program and stop the program. So why should you stop the program? When you stop the program, you have control over the program, right? For example, you can print the variables, you can change the value of a variable, you can do single stepping, you can put breakpoints and so on. So now to stop the program, we can use the command called break. Okay, so there is a command called as break. So break can be used to set breakpoints. Use of break is to set breakpoints. Okay, it can be used to set breakpoints. So breakpoint can be set in like functions. For a function, you can set a breakpoint. You can say stop at a function. You can set breakpoint at a line number. Okay, you can also set a breakpoint at a specific file. Okay, you can say file followed by line number. Okay, you can say specific file followed by function. So you can tell where to stop basically. Okay, so you can tell GDB to stop at a specific point in a program. So what all specific points you can specify? You can say stop when the function is called, right? Often we can see that, okay, let's say you're calling a function, let's say check prime, and you want to analyze the check prime function. You can say, okay, break at checkpoint function, right? Similarly, you can say, okay, break. Okay, I could see that, okay, there is a for loop there in line number 15. I suspect something is wrong at line number 15. So you can say, okay, break at line number 15. Oh, there is another file, let's say display.c, and in display.c, okay, line number 50, I see there is something wrong. Okay, it's not working as expected. So break can be used to specify where you want to stop the program. All right, hope it's clear. Okay, so let me show you how to use the break command. Okay, so you can say break. Now, which is the first function that is called in C? All of you know that it's main, right? I can say break in the main function. Okay, so when the main function is getting called, stop the program. Let's say break. That's it. So as you can see here, whenever I set a breakpoint, it will display an informational message break 1, right? I will set first breakpoint showing the function's address actually. Okay, and which file is this current file name, copy array underscore group.c, line number 4 it says. So if you look at the code, right, line number, let's say 4, right, you can see line number 4, towards line number 4 we have this main function. So we're telling stop at main function. All right, so we put a breakpoint now, break main. I can put a breakpoint somewhere else also. For now, let's see what happens. Okay, so what I did, I put a breakpoint. I can run the program. After setting a breakpoint, you can run the program. So immediately what happened, when you run the program, actually it is not completely running, it's stopping at the main function. So this is a very important thing you have to understand. By setting a breakpoint, I can stop the program at specific locations. Okay, now do one thing, I can do L, right? L means print the code. So I want to know what is inside main. I'll just do a L. So you can see in main arrays are declared. Okay, some code is there, etc. So we hit the breakpoint now. So what is that you can do next is the question, right? I can do something called as single stepping. So there is a command called as next. That means execute the next line of code. This is a very frequently used command, commonly used command is to do line by line execution. That is a good way to find out whether every line is executing correctly or not, right? I'll do next. So what does it say? Okay, array is getting created next, right? I can do next again. So what is the next line? So array got created, then you can see that it's executing the for loop, right? So in case you're not sure what is happening inside the for loop, you can do an L. Okay, I can see, okay, this it's copying, right? It's copying B to A to B. So next command can be used to do line by line execution. I'll do next. What's happening? You can see here, A of I is getting copied to B of I, right? So I can do this. I can do a next again by simply typing N also. That's a shortcut for next, which is called as N. So that means execute line by line. Now I'm not understanding what's happening here, right? I can see the loop is getting executed, but often you want to analyze the values. Let's say I want to analyze what is the value of I. I want to check what is the value of I. I can use the command called as print. Okay, so print command similar to your printf. Here we're using print command to check the value of a variable. I can say print I. So what is the value of I now? 0. It has not yet incremented. Yes, first loop is executed. After it, basically it's a executes the first iteration. I++ has not yet happened yet. Okay, so I is still 0. Let's see what is the value of B of 0, right? I can say print sorry for the disturbance, just a moment. Sorry for that. Let's continue. So I printed the value of I is 0. Let me print the value of B of 0. Okay, so what is B of 0? 1. So we could see here A of I has been copied to B of I, right? So it's showing the value of B of 0. Let's print B of 1. Let's see what is there in B of 1. So what is there in B of 1? Some random values there. Okay, let's see what is there in B of 2, right? Again, also some random value. So we could see that. So B is uninitialized, right? If you look at the code here, right? B is uninitialized. It contains some garbage value, right? So only the first iteration is executed. Hence, B of 0 contains 1, whereas other values are still garbage. Okay. Is this clear so far? Whatever has been discussed? Everyone? Okay, fine. What about others? Only Saurabh has responded. Okay, thanks. Why first iteration giving correct answer, Rahul? What do you expect? This is expected, right? After the first iteration, B of 0 has changed, right? So this A of 0 is getting copied to B of 0. So B of 0 should contain 1. Do you have shortcuts? Okay, Babu's asking like F5, F6 for line by line execution and direct execution. So that you can use it in an ID. Okay, like you can use VS Code, Babu, and you can do F7, F5, F6, etc. This is more of a tool called as GDB, which is used for command line debugging. Okay, so it may look less interesting, but it's very powerful. Okay, so in fact, when we use it for debugging very complex application, your VS Code and all might not help much. We can do a lot of complex things using this debugger. Soumya Raut, can you show insight how GDB works internally? That's not the focus of this webinar, Soumya. We are here to learn how to use GDB to debug a program. In fact, GDB uses some system calls like ptrace, etc., to basically stop the program. Okay, after stopping the program, we can analyze the program. All right. Now, let's see. I'll do next. Okay, I'll continue to do next. You can use n as a shortcut. Okay. Let's say you don't know what is the value of I, right? So you can use, let's say, code is executing, but you want to check the value of a specific variable, right? Continuously you want to print the value of a variable. So you can use, so print, what does print do? Whenever using print, it will basically print the value of a variable. Let's say you want to always print the value of a variable whenever next line executes, right? You want to keep checking the value of a specific variable. If you want to keep checking the value of a specific variable, you can use the command display. Okay? Display I. So display means continuously display that variable. Okay, so it is like you have a window over there which will continuously display the value of a variable. So I'm doing display I. Now observe what happens when I do next, right? So it's showing the value of I always, right? It's like always it will print the value of I. So this can be useful if you want to check the value of a variable is changing, right? When is the value of a variable changing? You want to check. In such cases, you can say display and the variable name to continuously monitor the value of a variable. So let me do next again. Okay, so you can see here value of I has become 2 now. So observe here, let me do print shortcut is P, can do B of 2. So what is happened here? B of 2 has not yet changed. Okay, so next usually means which is next instruction that is going to get executed. This is the next instruction which is going to get executed. It has not yet executed. Okay, so when you say N, it shows the next command which will get executed. Okay, it is not yet executed. That is why here B of 2 has not yet changed. Okay, so let me do a next again. All right, now let's check the value of B of 2. B of 2. So observe B of 2 has become 3. So hope this is clear. So we can use N to execute the next command. We can use P or print to display the value of a variable, right? We can use display to continuously display a variable. Is that clear so far? Okay, fine. Now I'll clear the screen by pressing Ctrl L. Let me do a next. Okay, so I'm doing next. Here I see that I is 3 yet, right? I'll do a next again. Okay, so notice here I can simply press enter. So enter usually means repeat the previous command. Okay, I keep pressing enter, repeat the previous command. So here I don't have to press n every time. I can simply press enter to repeat the previous command. So enter means repeat the previous command. So previous command was n. So I can use less commands. Like without typing, I can execute the previous command. Okay. So enter means repeat the previous command. So it's doing next only here. Next, etc. All right. It's printing the. Now what happened? It came after of the for loop, and it's on line number 18 now. Okay, so the code came out of the copy. Now it's in the print loop. Okay, this is the print loop now. I see that this I is equal to 5 is little annoying, right? It's every time it's printing the value of I. Now I has become 0. So how do you undisplay this? So display is there. Okay, so let's say you want to know more about the display command. I can say info and display. Okay, you want to get more idea about, sorry, more help on the display command. I'll say help and display, right? So display print the value of expression each time the program stops, it says, right? Whenever the next instruction executes and program stop, display. Opposite of display is undisplay, right? So let me undisplay now. Undisplay I, right? Or I can press tab, right? Undisplay I. Sorry. Or undisplay. Okay, I don't know. Let me see info display. I can see here one variable is there which is being displayed. I can say undisplay one. Okay, so undisplay, and you can give this number. So typically this sequence number is important. So this whatever we are displaying earlier will get undisplayed. So display opposite is undisplay. Okay, now if I do a next, it will not print the value of I. You can observe, right? It's not printing the value of I. Okay, so let's do next, etc. I can see the value of b of I is getting printed here. 3 it's printing. Next I'll do it again. Next, so you can see the value of b of I is getting printed. 4. Next I'll do, okay, again next, printed. 5. Again I'll do next. That's it. The program will terminate. So this was a quick demo of how to get started with GDB, how to run GDB, how to display variable using print statement as well as display statement, and how to set breakpoints. That's what we saw here. Any questions? Shall I move on to the next set of commands? Yeah, sessions are recorded. Yeah, it's getting recorded. All right, so that was about some of the basic commands. Now, let's see some more examples which are little bigger in nature. All right, so here is a program which is actually used to check whether a number is prime or not. Okay, so some simple program. Again, so if you look at this code, it's reading a number which we want to use it to check whether it's prime or not, and after that it's using a for loop to check whether the number is divisible by any number in the range 2 to square root of the number, right? So hope you're familiar with this logic, right? So if you want to check whether the number is prime or not, you divide by 2. If it is divisible by 2, then you will conclude it is not prime. Otherwise, you'll continue with the next number like 2, 3, and so on, right? So number will divide by 2, number will divide by 3, number will divide by 4, up to square root of the number. And within that range, if it is divisible, then we'll print it's not prime, and we'll set a flag and break, right? So this is the logic here. So let's compile this program and debug it. Okay, so I'll say gcc -g gcc -g and followed by -. LM since I'm using the square root function, sqrt function. Okay, so this will generate an executable. A.out file it generates. You can see A.out is generated. This is the executable. So prime check problem is there. So let's run this program using GDB. A.out. Alright, so again you can see reading symbols from the file, it's done. So what do you do first? If you want to check the code, you can just say L. Okay, I did L, it's displaying. I can press enter, it will continue to show the remaining code. Okay, you can simply press enter. Now what I'm going to do is that I want to basically put a breakpoint in main, let's say. I'll say break and main. I'm setting a breakpoint for main, and I also want to set a breakpoint in two other places. Okay, so I want to set a breakpoint on line number 19. Okay, and I want to set a breakpoint on line number 26 as well, or 25. Okay, so let me put a breakpoint on line number 19 and line number 25, because these are important points in the code which is required often to check if the code is executing correctly or not. Okay, now this line number 19 will enter if the number is not prime, whereas line number 25 it will always enter because the for loop will terminate and it will come right after the for loop exits. Okay, so let's put a breakpoint on line number 19. You can observe here, then line number 25. Okay, so total how many breakpoints now? 3 breakpoints, right? So if you're not sure how many breakpoints you set, you can say info. It's a command called as info breakpoints. Okay, to check how many breakpoints you have set, you can do info breakpoints. Right? I'll do info breakpoints. So you can see here, right? 3 breakpoints are set. So type its breakpoint, whether it's displayed or not, whether it's enabled or not, it's going to show, right? First one is at main, line number 9. Second one is in main, line number 19. Third one is in main, and line number 25. Okay. So what I'll do now is that I'll run the code. Breakpoints are set. I'll run the code. So observe what happens. Run. So what happened? It hit the first breakpoint, which is main. Now one option is I can do single stepping, right? I can do next, right? Let me do a next, right? Variables is showing, printf is there, right? Scanf is there. I'll do a next, yeah. So it's executing the scanf code. Printf, after printf, it's executing the scanf code. I'll enter a number, right? I can say number is 25, right? Then it's going to execute the loop. So I'm not interested to basically do line by line execution if the loop is going to be long, etc. Right? So what is the point? Right? Let's say a loop is going to run 10,000 times or 1 million times. You cannot do single stepping. Instead, what you can do is that you can set a breakpoint and stop at specific points. Right? Here you can see I want to stop at line number 19 and I want to stop at line number 25. So what you can do is that instead of typing next, you can say continue. Okay, so continue or C, anyone, right? Shortcut of continuous C. So continue means continue to the next breakpoint. Okay, continue to the next breakpoint. This is the next command. One more command I'm introducing called as continue. Continue means continue to the next breakpoint. So let me hit continue. All right. So what do you observe? It stopped at line number 19, right? So if you look at the code here, right, this for loop is executing and eventually it hit this, right? It entered this and there is a breakpoint at line number 19. So let's analyze, right? Let's analyze the value of variables here. So let me print the value of, so number, what is the number value of number? 25, right? Number is 25, right? So here you can see there is a variable called as div. What is the value of div? 5. So observe here, 25 is divisible by 5, right? So that is why it stopped at line number 19. So 25 modulus 5 is 0, condition becomes true, it reaches line number 19. Okay, so hope you understood what is the use of a breakpoint. So breakpoint has to be set intelligently. Don't put breakpoint just like that. So wherever you feel there are like entry exit points, some conditions to be checked, etc. Inside that you can set a breakpoint, and whenever it hits that line, it will stop. So this is one intelligent way to debug a program. All right. So let me do a continue once again. Okay. So I'll do a continue. It hit the next breakpoint. What is the next breakpoint? 25 line number. Okay, 25 line number. So it has it is not prime is already printed. You can see here 25 is not prime is printed. Let's check the value of flag. P flag. So what is the value of flag? Flag is 1 here, right? So flag is equal to 0 means number is prime. That's what we are doing. Flag is equal to 1 means it is not prime. We are set here. Okay, flag has become 1. Okay, let me do a next. Let's see what happens. So this condition should become false because flag is 1, right? I'll do a next. It's hitting the return 0 statement. Is that clear how to use the continue to debug using breakpoints? So break and continue, right? They are used in sync, right? You set breakpoints, then you keep doing continue instead of using next. Next means you're doing single stepping. Next. Continue means stop at a breakpoint. Okay. So this is a better way to debug. So you'll use a mix of all these things. You'll use break, you'll use continue, you'll use single stepping, and so on. So notice here, I stopped here, right? Then I did a next. All right. So let's do info breakpoint once again. All right. So you can see here, right? Breakpoint already hit 1 time, it says, right? It will show how many times the breakpoint is hit. First breakpoint is hit 1 time, right? Second breakpoint is hit 1 time, and so on. It shows. So let me say continue once again. That's it, done. Program terminated. So we analyzed with a value of 25, which is not a prime number. Let's take another value. Let's run it again. Okay, I'll run it again. So now observe here, once a breakpoint is set, it remains there. Okay, you don't have to basically set the breakpoint again and again for this instance of run. But when you exit the program, right, when you quit this GDB, again you run the program, the breakpoints are lost. It's temporary. Please understand this. Okay, so it will remain there only for this instance of the run. If you want to remove the breakpoint, okay, that's a good question. I'll show you. Okay, so you can delete breakpoints also. You can disable breakpoints also. You can remove also. Two things are there. So let me do next. Okay, next. You can do continue also, not a problem. I'll do continue. So it is doing a scanf here, right? Scanf means it's prompting you enter the number. So let me give a number which is bigger. Let's say 101. So 101, as we know, is a prime number, right? Let's say. So what happened? I did a continue. So breakpoint, which is at line number 19, did not execute, did not hit, whereas it reached line number 25. So what is the reason why it did not hit breakpoint at line number 19? Why it did not hit breakpoint at line number 19? Yeah, because that condition, it never reached that line, right? It's a prime number. The if condition never became true, so it never reached that line. Okay, so that's why it never hit the breakpoint number 2. Instead, it hit the breakpoint number 3, and wherein you can see it is reached 25. Now let's do one thing. Let's print the value of flag. Okay, So what is the value of flag? Flag is still 0. Flag did not become 1. If the number is not prime, flag will become 1. Number is prime, it remains 0 as per this logic. Right? Let me do a next now. Okay. Observe what's happening. So condition is true. I'll do a next. It should print it is prime. Right? It says 101 is prime. Okay, let me do a continue. That's it. So the program has terminated now. Right? So we used continue to put a breakpoint. After putting a breakpoint, to continue can be used to run the program continuously till it hits a breakpoint. Okay, continuously till it hits a breakpoint. Hope this is clear. Let's move on to the next set of commands. Okay, so I can delete breakpoints. Okay, so how do you delete breakpoint is that? So I'll do a help on delete. Sorry, Q to quit. Help delete breakpoint. Okay, so you can use the help command. It's a very good. It has a very good documentation. So there is a command called as delete breakpoint. Okay, let's say you want to understand how it works, right? I can say help delete breakpoint. So delete breakpoints, right? Or auto display expressions, arguments are breakpoints, numbers with spaces in between. Delete all breakpoints, give no arguments, right? It says that. So we know already that we already have a 3 breakpoints. So I'm using a shortcut B instead of breakpoint. Okay, 3 breakpoints are there. Let's say you want to remove these 2 breakpoints. These 2 I want to remove. So I can say delete breakpoint number 2 and 3. So 2 breakpoints I will remove, second one and third one. That's it. Okay, so I'll do info breakpoint now. Let's see what happens. Observe, only 1 breakpoint is left. The second one and third one got deleted. So this is also useful. Let's say you're putting a breakpoint, you feel that 1 breakpoint is not useful, right? You can remove it. Is that clear? Somebody asked this question. Okay. How to skip a breakpoint? Yeah, you can actually disable it. Okay, so you can disable it. I'll do one thing. I'll put a breakpoint once again. I'll say breakpoint and line number. Let's say 25. Right. So what happened? It added a breakpoint. You can see it assign a new number like a serial number, right? And info, if I do a breakpoint, you can see 2 breakpoints are there. One is in main, other is line number 25. I can see here it's like keep enabled. Yes is there, right? I can disable a breakpoint. I can say disable 4. So temporarily, if you want to disable a breakpoint, you can do this. Okay, you are experimenting, right? Temporarily, you can disable using disable. Now, if you look at the status of the breakpoints, you can see it is N now. It's not enabled, right? Yes means Y means it's enabled, N means it's not enabled. I hope it's clear how to disable a breakpoint. So delete means delete the breakpoint. Disable means temporarily disable the breakpoint. Okay, I hope I answered your question. All right. So let's move on. I'm going to remove the breakpoints. Okay, I'm going to delete the breakpoint number 4 now. If you look at breakpoints, only 1 breakpoint is there. Okay. Now, there is another way to set a breakpoint using something called as a watch command. So often what happens that you want to stop the program when the value of a variable changes. Okay, this is again very handy, right? So whenever the value of a variable changes, you want to stop the program. So this is called as a hardware breakpoint. Watch command is used for a hardware breakpoint. Okay, so it's called as hardware breakpoint. But in simple terms, what it means is that stop when the value of a variable changes. Okay, so whenever the value of variable changes, you want to stop It's like a breakpoint only. Okay, stop when the value of variable changes. So how do you use this? You can simply say watch and the variable name. So in our code, we have a variable called as flag, right? So I can say watch flag. Now in this context, nothing is there. I have to run the program first. Okay, since it's a local variable, first I have to run it. So as soon as you say run, the program started and it is stuck in main, right? It's stopping at main. Now I can add a watch point. Okay, I'll say watch flag. Okay, I'll say watch flag. So what does it say? Hardware watch point. It's adding one hardware watch point flag. So whenever the flag changes, it will stop. Okay, so it's an intelligent breakpoint again. This is not a line number, by the way, it's a variable. So let's see what happens now. Okay, anybody has any doubts, you can ask. Okay, so let's run the program. Let's continue the program. Okay, observe what happened. So old value of flag, it's showing 32767. New value 0. What happened? Flag value changed. Where did it change, by the way? It's showing line number 12. Okay, so it may not be exact, but here you can see line number 10, it's there. Flag is equal to 0. Okay, so flag has changed. It has been initialized to 0. Now let me do a continue again. Okay, flag changed to 0. Initially it was some garbage value. When the function started, it got initialized to 0. Let me do a continue. Let me do an L here. Notice flag will change here. Flag is equal to 1. It's going to change if the number is not prime. Okay, let me do a continue. It's asking me to enter a number. I'll enter a number which is not prime. For example, I'll enter 25. Okay, 25 is not prime. What happened? Again, it stopped, right? Hardware watch point number 5, right? Flag has changed. So what is the old value of flag? 0. What is the new value of flag? 1, right? Where it changed? Line number 20. Right? So you can see here, value of flag is changed. Flag has become 1. This is pretty useful. If you want to set a breakpoint when the value of a variable changes, you can do this. Now I can do a next. Right? I can do next. I can complete. Hope this is clear, right? How to use watch statement. So you can do an help on watch to get more information. Watch location, right? Or expression you can give. Right? So that's about the watch command. And this is also a command called as rwatch. Not be very useful. Rwatch means stop when a variable is getting used. Okay, rwatch and a variable, you can say stop when the variable is read or used. It's not like variable is changed and the variable is used. Okay, whereas watch is when the variable is changed. Rwatch means the variable is used. May not be very useful. Okay, but some situations you can use it. So if you look at our code, I can say, let's say, I can say, for example, rwatch number. Okay, so I'll do a continue. So I'll do a run once again. Let's say yes. New. Enter a number. Let me say 25. says 25 is not prime. So what happens is that this R watch will get deleted actually. Each time these watches will get deleted. I'll run once again. I have to add these watch points once again. Look at info breakpoint. You can see the watch points are not here. So I'll say R watch and number. Okay. So I want to basically stop the program whenever number is getting used. I'll do continue. Okay. I'll say number is, let's say 9. Okay. You can see value is 9. Number changed, right? I'll do a next. Here also it's getting used. Again it will stop. So wherever the number is getting used, it will stop. Okay, it will stop the program. I'll do a continue. Continue. So we can see whenever the number in the code, if number is getting used, it will stop there. So unlike watch, R watch will stop the program whenever the variable is getting used. Okay, so this is not so useful most of the times, but at times you can use it. That's about the rwatch command. Let's move on to some of the programs. Okay, I'll quit now. Say yes. On to programs which use functions maybe. Okay, let's look at programs which use functions. Okay. So this code has some bugs, but let me remove the bugs for now. Later we'll use these bugs. Okay. So analyze this code. So there is a main function. Main function, we are defining an array of integers, and we are calling the average function to find the average of an array. So this function will take an array as an argument, size of the array, will return the average of the array, here printing the average. Simple program. Okay. So let's see what the average function does. So look at the average function. It takes the integer array as an argument and the size of the array. And here, actually, it is not finding the average using a loop. It's calling the sum function, and sum function will return the sum of the array, and sum divided by array size will give you the average of the array. So what does the sum function do? The sum function, let me modify it. Let me make it as a double only. Idea is not to confuse you. Okay. Now I'll make it easier for you. Okay. So this sum function will find the sum of the array. It will return the sum. So let's compile and run this code. gcc buggy.c. Syntax error. Line number 6. Number 6. Yeah. So I compiled it. Okay, I have to compile it using -g option. Please remember this. Compiled it. Now let me run it using GDB. Okay. Then run this program. Let me put a breakpoint in main. I put a breakpoint in main. So you can set by default whenever you're running a program, you can set a breakpoint at main, and later you can add more breakpoints. That's what I would suggest. Okay. right? So now I can add breakpoints also, but I'm not going to add breakpoint here. Let me run the code. Okay, R4. So program stopped. Let me display the code. You can see it's going to declare the array and call the function average. So let's do next. I do array got created, function. Next line, the function will get called. Yeah, function got called, function returned, right? You can see 30, 31, and it's going to print the average, right? So this is what we've been doing so far. We're using n command to basically do line by line execution. Let's say you want to go inside this function average. Now what's happening is that this line by line execution, we're not able to analyze the function code, right? So if you want to analyze the function code, you want to get inside a function, you have to use a command called as step, which has a shortcut called as S. Okay, so instead of n, you can use. Let me run the code again. Okay, it's asking you want to start the program from the beginning. I'll say yes. Okay, so current program is terminated. I'll do next. So instead of doing next, I want to step inside the function. Okay, to step inside the function, you can use the command step or S. Okay, let me use step here. So notice here it will not go to the next line. Instead, it will go inside the function. So I'll do a step here. So what do you observe? It is inside the average function now. Okay, so it shows the arguments also. A is an array, its base address is getting passed, n is equal to 3. Now you can analyze the value of array also. I can say p star a, right? Or you can say p a of 0, right? Or you can say p a of 0 at 3. Okay, so observe I have introduced new syntax here for arrays. So array, if you want to display multiple values, okay, you can say p. Usually here one value you want to display, you'll do like this: print and the array element. If you want to print multiple values starting from 0th index, you have to say at and a count. Okay, you'll say at and a count. Here I'm telling print array of 0 at count. That means print first 3 values. Okay, it's going to print the first 3 values. So this is very handy to print arrays. Okay, it's very handy to print arrays. Hope it's clear. So now we are inside the average function. How did you get inside the function? By doing a step. Step command can be used to go inside a function, right? So if you look at the code now, okay, sometimes I will get lost. I don't know which line is currently executing. Where did it stop, right? I can say where. So where is a command which can be used to check where is the program currently stopped. So it's showing that, okay, program is currently stopped in average at line number 19. Okay, so this is a very useful command. You can say where, or you can say bt, okay, or backtrace. Okay, backtrace you can do. So both are same actually. It's aliases. Either you can use where or you can use a backtrace. What is the use of this where or backtrace command? So it will tell you where is the program currently stopped at. And it also shows something called the call stack. Okay, how did the program execute, right? First you can see here it executed main, and in main on line number 30, if you observe, this average function is getting called. So from main at line number 30, there is a call to average function. It jumped to the average function. Now in average function, it's at line number 19. Okay, so I can do L19 just to display line number 19 also. Okay, what is that? Line number 19. Okay, line number 19. The next line is going to be some function. So I'll do one thing. I'll do a step again. Okay, I'll do a step. I want to go inside the sum function. I'll do a step. What happened? It is now stopped at sum. Sum is the next function, right? You can see it stopped at sum. Let me do a next. Okay, so here you can observe there is a for loop. Next, right? It's doing sum, next, 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 and so on. Next, next. Now the for loop will terminate. Okay, condition became false. Let me print the value of sum. Okay, sum shows 5. 1 plus 2 plus 2, it's 5. Now I can do a step inside a function, right? Let me do a where once again. I'll do a where or a BT. BT is a backtrace, or where both are same, and type it. Right? We can see what is the where is the program stopped at. Program is stopped at line number 11 now. Okay, you can see return sum. Stopped at line number 11. So from main it jumped to average. From average it called sum. Now it's at line number 11 at sum function. So I hope you're getting this. This is called as a call stack or a backtrace. Okay, backtrace or a call stack. So it shows how the program executed. Okay, this is very useful. Now you may ask, what is the use of this, right? What is the point of using a backtrace? So you can find out the flow of execution actually. So one more useful command is there is something called as local variables you can print. Info locals you can. Now I'm inside the sum function. Inside the sum function there are two local variables, right? I and 3. I and sum. What is the value of I? 3. What is the value of sum? It is 5. Let me print the sum function. You can print a function by giving the function name also, L and sum. Observe what's happening, right? So you can see two local variables are there. Okay, I and sum. So we can display local variables by using info locals command. Okay, so it'll display the local variables for the current function stack. You can also display parameters, arguments, info args. Okay, so function arguments you can display by using info args. Okay, by the way, this is an array. That's why it's showing the address. So two commands you learned: info locals to display the local variables, info args to display the arguments. Okay. There's something called as info stack. Okay, it's going to show the same thing. So that's about breakpoints and displaying local variables. So I'm inside where I am. I'm inside the sum function. Let me do a next. It's going to return. So the sum function returned, right? So notice here, it's an average now, right? It's inside the average function. Now let me print the value of average. It's printing 1.667. So the sum function is already destroyed now. It returned, it jumped in, it returned back to the average function. Let me do a backtrace once again. Observe the sum function has been destroyed, right? Because it returned. Let me do a next again. Notice here now the average function will return. Okay. Let me do a BT once again. Observe the average function also has been returned and it has been destroyed. So whenever the function returns, the stack information will get destroyed. Now only main stack exists. Let me do a next. You can see it's printing the average. Okay, so I can do continue just to terminate. So is this clear? So we learned about how to use step command, and how to use backtrace or where command to display the stack trace. Okay, and info locals as well as info arguments. Okay, let's move on. Let's move on to some more examples. Okay, now the same example, what I'll do is here. Let me see what are the other commands useful. Break, delete, clear breakpoints, enable, disable. watch, so watch, yeah. Line number, break, okay, back trace we saw, right? Step we saw, next we saw finish until the current function returns, okay. Finish and print we saw, right? Yeah. Okay, let's discuss another program, same program, but I'm going to introduce a bug here, okay, which is nothing but a segmentation fault. Observe here, it's a null pointer. I deliberately initialized it to null, and I'm dereferencing a null pointer. So many a time what happens is that when you write programs using pointers and use dynamic memory allocation, etc., at times you may write buggy code wherein the pointer is not used correctly, right? If the pointer is not used correctly, then the program will give segmentation fault. So GDB can be used to quickly debug programs with a seg fault. Now this is a very small code, but if it's a very big code with thousands of lines of code and the program crashes due to some reason, due to a signal, etc., so GDB can point you to the exact line number which caused the crash. Okay, let me do this. GCC buggy.c -g. Okay, I'll run this. You can observe what happens. Okay, it generates a segmentation fault and it shows core dump as well, right? Now what I'll do is, instead of running it directly, I'll run it using GDB. Now this is the explanation for how to analyze segmentation fault using GDB. So GDB a.out I'm doing. I'll run. Okay, I'll run the program. Observe what happens. Okay, so what did it say? It says the program received signal 6 segmentation fault. So we know that the program is terminating abnormally. It's not a normal execution. Because of a buggy code, it is terminating because of a null pointer dereference, right? So here it says this line number is causing the seg fault. Star PTR is equal to 50 is causing the seg fault. What you can do is you can simply print the value of this PTR. Let's see what is the value of PTR. Observe here, PTR is 0. That means PTR is null and we should not dereference a null pointer. So GDB can be used to quickly analyze a code which is generating a segmentation fault or any signals which is causing the program to terminate. So is this clear? How to use GDB to analyze code with the segmentation fault, etc. Okay, so this is very powerful actually. Okay, many a time when you write code in future, this is going to be very helpful. So let me quit this for now. Let's see. So that's about analyzing segmentation fault. So few more things are left. Okay. Yeah. So you can actually change the value of certain variables also. When you're running a code, right? You can also change the value of variables. Yeah. So observe here. I'll run the code once again. A.out. Okay. It says segmentation fault core dumped. Now somebody is asking what is the meaning of this, right? What does core dumped mean? I'll recompile the code once again. Let me do GCC -g buggy.c -o buggy. Okay, I'm doing this. So many a time the program name which you give is same as the C file name followed by the without the extension, right? So if I run this buggy code, yes, we see that it's generating a segmentation fault. And it says code dump. So what is the meaning of this code dump is a question. So if we do an ls minus l, one second. Core dump, let me change the limit settings. Limit, let me say core dump. I have to enable the core dump file actually, or it's 1 second. Core file size 0. Let me increase it. Limit minus c. Let me set it to blocks. It's not generating the core file. Yeah, I think I have to change some of the settings in the that is 8.94. We'll see that later, how to debug the core file. So typically when you the program crashes, generate a core file. In this instance, not creating. I have to check where the file is getting generated. But core file can be used to actually check how the program crashed. Okay, so for example, this core file is generated by the operating system whenever the program crashes. Okay, so what is core file? So whenever, right, whenever a program terminates abnormally, the OS can generate a core dump or a core dump file. So what does this file contain? So this file contains the stack trace, okay, of the program. Okay, so stack trace of the program means, for example, it shows the call stack. It will have the information about variables, values, etc. So what is the use of this? You can attach it to a debugger like GDB and analyze the crash. So often when you're working on Windows, right, sometimes whenever application crashes, it shows a pop-up, right? The program crashed. Do you want to send a report? You'll say yes, send report. No, and send report. Usually we'll say no, right? Have you seen such messages whenever a program crashes on Windows? They'll show a pop-up, right? My program crashed due to some reason. Do you want to send the report to Microsoft? Right? I don't know whether you've seen such messages. Yes? Okay. So what is that when happens when you send the report as a question? So when you send a report, it contains a core dump or a crash report. So what is the use of that crash report? That crash report contains the program called stack trace, which can be attached to a debugger, and you can analyze it how the program executed exactly. Like we saw, right, BT command it's showing, right? When you do a BT command, it shows what is the call stack sequence, what is the value of variables, etc. So this is pretty useful. These crash reports are useful for the developer. Developer can use it and attach it to a debugger and find out how the program terminated exactly. Okay. Now, how to generate the code dump? It depends on the operating system actually. Right now, I'm not able to find the location of the core file. Okay, but we can change the settings to generate the core file in the same folder. I think now it's not getting generated in the same folder. It's saving it somewhere else. Maybe in some proc directory it's saving it. I need to check the location of the code dump file. All right. So next, what we'll do is let's move on to So we could also set the value of variables. So let me show you with an example. Okay, I'll take a simple example here. Okay. So here there is a program which is actually taking some argument. This function is taking some argument and it's finding the sum and product of two numbers. Okay, so sum of num1 and num2 is getting stored in star sum pointer. Product of num1 and num2 is getting stored in product pointer. And we are calling the function from main by passing 4 arguments, right? 2 are passed by value and 2 are passed by reference. All right. So let me compile this. Okay, let me do a GCC GCC -g GDB error out. Okay. So now this demonstration is to show you how to change the value of a variable. Okay, so I'll put a breakpoint. Let me do a list, right? I can see what's happening. I'll do next. Program has not been run. Let me run it. Okay, I'll do a next. So I can see value of a. P is 5 here, right? P B is 10 here. Sorry, P B is 10 here. Now let's say you continue this program. You can see, right? Sum is 15 and product is 50. So 5 plus 10 is 15. 5 into 10 is 50. Now in this code, I have not used scanf. Okay, there is no scanf here, but I want to change the value of A and B. So what is that you can do? Is the question, right? Can I change the value of some variable, let's say, without changing the code? Right? This at times this will be important, just to maybe change the value variable and see the program is getting correct output, etc. So you can do that. I'll show you how to do that. I can say run once again, and I'll do a next. Right? Let me do a next. We know that A is 5, right? And we know B is 10. I want to change the value of A. I can do set, for example, A is equal to, I'll make it as 3. Okay. I'll change the value of B also. I'll say set B is equal to, let's say, 25. Let me print the value of A. A is 3. Let me print the value of B. So how do you change the value of a variable? This is one way, right? You can say set and the new value of the variable. Set new value of the variable. So I can change the value of any variable at runtime using GDB. Okay, this is pretty handy. Okay, at runtime we can change the value of a variable. Let me do a continue now. can see sum of 3 and 25 is 28, product is 75. So set command can be used to change the value of a variable. Hope that is clear. Yeah, Babu's asking, segmentation for error means something related to referencing to an invalid address. Yeah, correct. That codem file is not reproducing bugs. I'm not sure what you meant. So the core file, it is generating somewhere else. I need to find the location of it. It's not generating in the current directory. Yeah, Soumya is asking thread debugging using GDB. Yeah, I'll show you that. Okay, that's the last thing I'm going to show you. So is this clear? How to basically do this? How to change the value variable? All right. So let me run once again. Okay. In fact, you can do much more things. For example, I can call a function also. Okay. So you can call a function which is not there, which is like additionally you can call. I can say printf. Hello. Okay. So inside GDB, if you want to call some other function, you can also do this. I can call that. I can pass arguments also. When you say call and the function call, will call that function and see the output also. Right. This is also sometimes useful. So call can be used to call a function as well. Okay. So hope this is clear. Now, what is left? Yeah, debugging. What is that? Threads is important. Maybe I'll cover that. With this. Maybe one more important thing is that how do you set arguments? To pass arguments to a main program. Okay, so here example which uses main. Functions are two main arguments. Right. So let's see how we can pass command line arguments using GDB. Okay, so here I could see that there is a program called as command average.c. So this program takes command line arguments. You can see argc and argv here. Okay, and I think it takes some numbers as an argument, right? Usage number 1, number 2, etc. So you need to pass command line arguments when to find the average of the command line arguments. So don't worry about what is the program doing. Let's see how we can pass command line arguments. So you may think I can do gcc then minus g command average, right? And if I do gdb dot slash, usually you can do this. I can do dot slash a.out and I can pass some arguments 1, 1, 2. Right? It's printing averages 1.33. Now, how do you do this using GDB? How do you pass arguments to the program using GDB? Let's try. Okay, I'll do GDB a.out and 1, 1, 2. Actually, it doesn't work. You can see it prints this error message. Right, a usage function is getting called. In fact, so to pass command line arguments, this is not the way to do it. Right, this is not the way to do it. You can't do like this. There are two ways. One option is we can run the program, and here after running the program, we can set the arguments. You can say set args. It's a command called as set args. I can pass the arguments to main. Set args 1, 1, 2, for example. That's it. And I can put a breakpoint, for example, in main. So to set arguments, to pass arguments to main, you can do this. Set args and the arguments you can pass. Let me run this code. You can observe what's happening. I'll do a next, 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 right? Next. So I'll do a print sum. You can see, right? Sum is 1. So how do you set arguments to main? We can pass arguments by doing set arguments and the arguments you want to pass. Okay, hope this is clear. Do a continue. See, it's printing the average. Let me pass some other arguments. I'll say args, let's say 10, 15, 10. Then I'll do a run. Okay. Oh, I put a breakpoint here. I can do a continue. It's printing the average. So this is how we can set the command line arguments. So after starting GDB, you can set the arguments by doing set args and the arguments you want to pass. So hope this is clear. How to set arguments inside GDB. Command line arguments. So let me wait this. So let's move on. Let me move on to multi-threaded programming. Just give me a moment. It's not there in this folder. Yeah, I'm not shared. I'm just sharing another screen to show you how to debug threads. Just give me a minute. Okay, so let's get started. Let's assume there is a program which contains 2 threads. Okay. One second, just a second. I'm just copying the contents. So, hope screen is visible now. Okay, thanks. So let's take an example code which uses threads. Thread, simple thread maybe. Okay, so here, if you observe this program, I'm assuming that you are familiar with threads. So this is a program which uses pthreads to create 2 threads to execute 2 different functions. So there are 2 functions, print x and print pos. Okay, so print x and print pos is simply actually running a while loop and printing a character to stdr. So print x will print x continuously and print o will print o continuously. So in the main function, we are creating 2 threads. One is thread 1 and second one is thread 2. Okay, so pthread create can be used to create threads. So we're using pthread create to create thread 1 and it will execute the function print x, and pthread create to create second thread and execute the second function, which is print o. Okay, so let's compile this code. Let me do one thing. I'll copy this to Linux because this is WSL. Okay, I'll copy it in Linux. It will be better. So let me compile this. GCC -g threads -lp thread, and pass the library flag to add the pthread library to be linked. So I'll run this. If you observe this program a.out, it simply prints O's and X's. Okay, it simply prints, that's it. By the way, this program is not doing anything that useful, but let's see. Okay, let's attach it to the debug. Idea is to see how we can basically put how we can analyze the threads. Okay. Yeah. What I'll do is I'll add a breakpoint in main. Okay, I'll show the code once again. You can observe thread is getting created in main, and there is a while one. Okay, so let's do one thing. I'll do a single stepping here. Sorry, not run. I'll run. It started running. I'll do next, next, next. You can observe, right? I'll do a next. So you can see what's happening here. It's like a multi-threaded program. Two threads are printing messages O and X continuously. So what you can do now is the question: how do you stop this program so that you can analyze this? One option is you can press Control C. I press Control C, the program terminated, right? So the main thread actually terminated. So this is not working. So we'll do one thing. We'll uh, run the program once again. Okay, so sorry, we'll put a breakpoint. So we'll say L1 variable lock. It says continue. Okay. So yeah, it's not actually stopping. Put a break. So where is it stopping? I press Control C. It says thread 1 a.out received sig interrupt. So let's do one thing. Let's do info threads. I just want to see what's happening. Okay, I can do an info threads. When you do info threads, it's going to display how many threads are there. Okay, so I can see that there are 3 threads created. Thread 1, which is in main, and thread 2 and 3 is doing something else, right? It says lock, wait private. It's saying something else. Now, what you can do is you can put a breakpoint, okay, on a thread. I can say B breakpoint. Breakpoint. I can say thread. Okay, so, and you can pass apply. Okay, and I can say all, or I can say, let's say 2. I can say thread apply to BT, for example. Okay, so these are little advanced things. This program is not appropriate to show you that. So typically what happens is that when you actually create a multi-threaded program, all these threads will be executing independently. Now, to do something which is thread specific, you can use a command called as thread. Okay, that's a command called as thread. You can say apply. So which thread you want to apply, you can specify. You can say that for the second thread, apply the command BT. So what it means is that show the stack trace for the second thread. So notice here how the stack trace looks like. So currently you can see here, in fact, the pthread create command, right, is called pthread create internally invokes a system call called as clone, and we can see that cloned thread is executing a function called as printx, and from that printx actually putc command is getting executed. Now you may wonder what this is. I press Control C, that's why it stopped. Okay, that's why it stopped. So I can individually analyze different threads by using thread apply command. I can say thread apply 1 VT, right? So you can observe here the main function is also a thread. It stopped at line number 30. So I can also say thread apply, let's say third thread and a backtrace, right? So you can do such things. We'll show the backtrace of the third thread also. So yeah, I'm here in print O, right? So executing print O command. Now, We'll modify this code a bit so that we can do something a little bit more useful. I'll use another example that's better. Cat thread not set. Okay, let's take this example. And compile this. So here you can see in this code there is a main program, and inside main multiple threads are created. So thread 1 is going to execute a factorial 1 function. Thread 2 is actually executing a second factorial function, fact2, and thread T is executing another factorial function. So 3 threads executing 3 different functions, and these threads are also taking some argument as well. Okay, they're taking some argument as well. Fact calculator is doing something. So let's compile this code. gcc -g thread2.c. So don't get into the details of the code. Assume that there are 3 threads are there. 3 threads are executing 3 different functions. Sorry. Okay, let's see how to debug this program. So I'll say GDB a.out. So I'll put a breakpoint in main. Okay, so then what I'll do is I'll put a breakpoint in fact underscore method. There are 3 functions, right? So actually, if you want to break, if you notice here, the 3 different functions are there: fact 1, 2, 3. Now, often what happens is that you want to set a breakpoint on similar functions. So in such cases, you can say R break. Okay, so R break is there. So what it means that regular expression break it is. You can give a pattern. I can say break on functions starting with fact method start, right? So that means all these 3 functions I want to put a breakpoint. This is very handy. I want to give a regular expression, you can use R break. Okay, so you can see what happened. It could see that there are 3 functions: fact method 1, fact method 2, fact method 3, right? 3 breakpoints it's setting: method 1, method 2, method 3, right? So let's run the code. Okay, it stopped at main. Let me continue. So observe here, you can see thread 2, right? Breakpoint is hit. Thread 2 is executing fact method 1, so you can see the breakpoint is executed here, right? So let me do a, now it's little difficult because 3 threads are executing separately. So if you want to analyze a specific thread, you can actually say thread, right? Let's say apply to bt, and observe here thread 2 is executing. Thread 2 is hit the breakpoint fact 1, right? And fact 1 method you can see here. So you can do thread apply to info locals, right? So you can give a prefix actually. So we used to do info locals earlier. So it means display all local variables. But in this case, since 3 different threads are running or 4 different threads are running, you have to specify for which thread you want to execute the command. So I want to execute the command for thread number 2, right? So let's say you want to execute the command for thread number 1. I can say thread apply 1 info locals. Okay, so I'm doing thread 1 apply locals, it's showing something, right? For thread 1, what are the local variables it's showing? So like this, you can use a prefix like thread apply. You can say apply all also, and you can say info locals. That's also possible. It will show the value of local variables for all the threads. Let me do a continue. You can see it hit the breakpoint at 3. So switching, it says switching. So what happens is that when you're debugging in GDB, you can actually debug only one thread at a time, and you can keep switching from one thread to another, right? You'll have to keep switching from one thread to another. So we have to use thread apply, let's say 3 dt, or you can say thread apply info 3 info locals and so on. So apply. So thread number 2 actually terminated. So here you can see they run it in parallel. So one thread terminates, you cannot basically debug that thread. Whereas thread 3 is still running, you can see thread 3 related information. So this is about how you can debug multiple threads. Okay. So due to time constraint, I will not be able to proceed further. I think it's already 9:11. But this was just a quick introduction about how to use thread related commands to debug threads. Any questions you have, let me know. So I have some questions. Yeah, somebody's asking, will it be uploaded on LMS? Yeah, we'll share it to you. And what does null argument mean here? I think Naman is offline. So what exactly is symbol file? Yeah, so I mentioned that debugging symbols are added to the executable. Are you talking about that, Soumya? Yeah. So when you compile a program, right? So program will get converted to binary. So this binary instructions can be executed by the CPU, and it will basically execute instruction by instruction. Now, if you want to debug a program, you should have additional information, including the source code of the program. So if you give a binary and binary does not contain actually any source code related information. So what GCC -G does is that along with the executable, it adds an additional basically segments, so that when you debug the program, you can refer to the source code. The source code is not there, the debugger will not know about what variable is there, and will not be able to basically compare the statements that are executed with the actual lines. So that is the reason the -G option is used. If you don't use -G option, GDB will not be able to debug the program. Yeah, there is a quiz. So give me 2 minutes. I'll share you the link to the quiz. You can take up the quiz, and whoever basically gets the right answer for the quiz will get a set of goodies. So Nanda Kishore is asking, is your institute for professionals up to what experience, online or offline? So Nanda Kishore, I'll share the email ID. You can get in touch with them. Please send an email to training@emertxe.com. You will get more details. Will you receive a certificate for this? Actually, we are not giving any certificate. This is more of a knowledge sharing session wherein you will gain knowledge. It's just a 2-hour session. So there is a quiz. Let me share you the quiz details. Just hold on for a minute. Just 2 to 3 minutes. You can wait. I'll share you the link. So I'll stop the recording now. You can take up the quiz. So, and just to conclude what we learned in today's webinar. So initially I gave an introduction to what is GDB, and after that we had a quick overview and walkthrough of how to get started with GDB, how to compile GDB, and how to run the program, how to set breakpoints, and how to do single stepping, etc. using Next. Then we saw some more additional commands using GDB, including printing the variables, then displaying the variables, setting breakpoints, using info command to display the information about breakpoints, disabling breakpoints, right? We saw how to use print to print an array. Then we discussed about how to use backtrace command using bt or where command to get this call stack information. We also saw how to use watch command to set a hardware breakpoint. Then we discussed about how to use continue to continue a program. We saw how to set arguments so that you can pass command line arguments. We saw how to debug a program to analyze a segmentation fault. Then we also discussed how to basically print local variables and how to print arguments. And finally, we saw how to basically debug threads using thread commands as well. So hope you are able to get a good idea of how to get started with GDB to debug programs. So this is just a beginning. So going forward, you can practice whatever you learned in this session, and you can use this tool to effectively debug complex programs, as well as in future when you get a job, it's going to be very handy for you so that you can analyze the code as well as easily find the root cause for programs. So with this, I would say thank you all for attending this webinar. And if you have further queries, you can reach out to us as well. So if you have any questions, you can post the questions in the question pane. I'll be happy to answer you.